Okay, now let's look at question number 2. Okay, so question 2 says, find the equation of a line through the given point and having the given slope. Express the equation in standard form. Okay, so let me remind you what standard form is. So the standard form of linear equation or linear relation, standard form, it looks like this, okay? AX plus BY plus C is equal to 0, where A, B, C are all real numbers, okay? I've been using this symbol a lot, okay? This symbol, because eventually, at one point in your life, you'll see this symbol in some of your math classes. Okay, so this symbol means belong to. I think this is not the first time I introduced this to you. Okay, so this means belongs to. Okay, and this weird, so this is just an R, right? It's just a weirdly written R. This symbol over here represents the real number set. Real number set. Okay, so basically this whole thing over here basically means A, B, C are all real numbers. Okay, A, B, C are all real numbers. So this is standard form. And number 2, it says, use the equation to find 2 other points on the line. Check your solutions. The check your solutions here is kind of weird. How do we check our solutions? So this is how we check our solutions. We find the equation based on the information given, right? We're given a point, like let's use A as an example. So we're given a point, we're given a slope, right? We're given a point and we're given a slope. We can use these 2 information to find the expression of the straight line, right? And then we pick different x values. We pick another 2 different x values and we find the 2 different corresponding y values. And if the slope that we use those 2 points to find is the same as this slope, that means the 2 points found based on the expression are correct, which proves that the expressions here we find are correct, right? So it might sound a little bit confusing. Let's proceed. Let's see like what that means. So we're given a point 5 minus 3, and we're given m, which is slope, which is equal to 1 over 3. How do we solve this? First step, we let x, y represent all points on the line, on the straight line. Right? So this xy here, we've talked about this, right? This xy here represents all points on the straight line. It's a generalized form of all the coordinates of the points on the straight line, right? So we use xy to represent all points on the straight line. What's the second step? We use slope formula, right? Use slope formula. M is equal to y minus 3 over x minus 5, right? And the slope is given here. So this is equal to 1 over 3. This is equal to 1 over 3. And this gives us y minus 3 is equal to 1 plus 3. So 1 plus 3 over x minus 5 is equal to 1 over 3, right? So now we just need to use some very simple mathematical operation to move x minus 5 to the right side of the equation, we basically multiply x minus 5 on both sides of the equation, right? So the left side will be y plus 3 because x minus 5 on the numerator and x minus 5 on the denominator will cancel out. Is equal to 1 over 3 times x minus 5. Okay. Simple as that. This is the point slope form of the equation. Okay, this is the point slope form. So this is your answer for part 1. Standard form. How do we change this to standard form? Let me remind you again. Standard form looks like ax plus by plus c is equal to 0. Okay, so how do we change this form to standard form? First of all, we need to move everything to the left side of the equation and leave the right side 0. That's the first step, right? And then we need to open all the brackets and combine all the constants. Okay, and then we organize the equation. It will look like this form. So let's try. First of all, y plus 3, we move everything on the right side of the equation to the left side of the equation, minus 1 over 3 times x minus 5. Now the right side of the equation will be 0, right? And now we open the brackets. Okay, so y plus 3 minus, okay, so let's not open the brackets yet. Let's multiply the coefficient in, like, so let's factor the coefficient in the brackets first. So minus 1 over 3x minus 5 over 3 is equal to 0. So this step, I basically use the distributive rule, right? Multiply this and multiply this. Okay. And this gives us y plus 3. Okay, so this is a minus sign. What do we need to do if the sign in, like, before brackets is the minus sign? When we open the brackets, we need to change this to plus. Okay, so you really need to be careful with all the small stuff. Okay, so now minus 1 over 3x plus 5 over 3 equal to 0. Okay, now we move the x term to the front. This gives us minus 1 over 3x plus y, and we combine the constants, right? So 3 is equal to 9 over 3, right? 9 over 3 plus 5 over 3, that's 14 over 3. So plus 14 over 3. This is equal to 0. So this is the standard form that we need to find. Okay, so part 2, basically we used some very simple mathematical operation to change the point slope form to standard form. So now 2 other points. This is the fun part. This is the fun part. So let's use the point slope form. Y plus 3 is equal to 1 over 3 times x minus 5. Okay, so let's recall what we did. How did we find this expression? We found this expression based on the point and the slope, right? How do we know that there is no mistake in all these steps? If we take different x values and we find different y values, so let's say we found another 2 points, okay? If we can find the slope using these 2 points, and see if the slope that we find here is the same as this one. This is how we check whether our answer is correct. Okay? So let's just do that. Okay. Let's let x be, for example, 5. Oh, we can't let x be 5 because the point given is 5 minus 3. So for example, let's let x be 8. Okay. If x is 8, then y plus 3 is equal to 1 over 3, 8 minus 5, right? So my y plus 3 is equal to 8 minus 5, that's 3. 3 times 1 over 3, that's 1. Right? So this means y is equal to minus 2. This means 8 minus 2 is on the straight line, theoretically, right? So this is the first point that we found. 8.2, sorry, 8 minus 2. Let's use another x value. For example, let's make x be equal to, let's say, 2. If x is equal to 2, then y plus 3 is equal to 1 over 3, 2 minus 5, right? And this gives us y plus 3 is equal to 2 minus 5 is minus 3. Minus 3 times 1 over 3, that's minus 1. So this is minus 1. This means y is equal to minus 4. This means 2 minus 4 theoretically should be on the straight line as well, right? So now we can use these 2 points to find the slope, right? So m is equal to minus 4 minus 2 over 2 minus 8. Minus 4 minus 2, that's minus 2. And 2 minus 8, that's 6. So the slope is equal to minus 1 over 3. So this is the slope. Is it the same? Sorry, 2 minus 8, that's minus 6. Minus 6. Okay, so the answer should be positive 1 over 3. So this is the slope that we found based on these 2 points, which we found based on the expression that we found, right? And the slope that we found is equal to the original slope given in the question. And this gives us the conclusion that the expressions that we found were correct. Okay, so this is how we check our answer. Okay, this is how we check our answer. Part B. Part A and Part B are essentially the same. Okay, let's quickly do Part B as well, because I know point slope forming is difficult. So let's just practice more. Okay, so we're given a point 0.6, 0.1, 0.3, sorry, and the slope is equal to minus 0.1. So the slope, point slope form again, xy. We let this be the general form of all the points on the straight line, right? And the second step is we use the slope formula, m. This is equal to y minus 0.3 over x minus 0.6. and the slope is given, which is minus 0.1, right? And then we use some mathematical operation to move x minus 0.6 to the right side of the equation. So this is equal to y minus 0.3 is equal to minus 0.1 times x minus 0.6. Okay. And this is the point slope form that we need to find. Okay. So this is, if you compare the steps of part A and part B, they're exactly the same. Okay, they're exactly the same. So how do we find standard form? Standard form is ax plus by plus c is equal to 0. So again, essentially we need to move everything to the left side of the equation and leave the right side of the equation 0. And then we open the brackets, we combine the constants, and then we can find this form. Okay, so y minus 0.3 plus, so when we when we move this to the left, we need to change this minus to plus, right? So plus 0.1 times x minus x 0.6. This is equal to 0. So in this step, we moved everything on the right side to the left side. Okay. And y minus 0.3 plus, now we use the distributive rule to open the brackets. 0.1x minus 0.1 times 0.6, which is 0.06. 0.06. This is equal to 0. Okay, now we move x to the front. 0.1x plus y is equal to minus 0.3 minus 0.06. So sorry, now equal. So that's minus 0.36 is equal to 0. Okay, so this is the standard form. This is standard form. 2 other points. This time, let's use the standard form to find 2 other points. Okay. So we take different x values and we find different y values and we check the slope. Okay. So if x is equal to 0, for example, if x is equal to 0, then 0 plus y minus 0.36 is equal to 0. This gives us y is equal to 0.36. So the first point we found is 0.36. Okay. Now, if we let y be 0, then 0.1x minus 0.36 is equal to 0. This gives us 0.1x is equal to 0.36, which means x is equal to 3.6. Right? So the second point we found is 3.60. So now we have 2 points. What do we do now? We use the slope formula to see if the slope we found here is equal to the original one over here. Okay. So this is equal to y2 minus y1 over x2 minus x1, which is equal to 0 minus 0.36 over 3.6 minus 0. Okay. So this is equal to minus 0.36 over positive 3.6. This is equal to minus 0.1. And minus 0.1 is equal to the minus 0.1 over here. And this proves that our solution is correct. Okay? So that's question number 2. So I strongly encourage you to do question number 2 more than once, okay? Because after you like watch this video, you might think, okay, it's not that hard, right? I understand. But if I change the number, okay, if I change a scenario, you might not be able to solve the question. Okay, so I strongly encourage you to practice this question more than once. Okay, just do it over and over again until you feel super comfortable with all the steps. Okay, so that's question number 2. Question number 3, determine the equation of a line. Express the equation in standard form. So again, standard form. Okay. Through minus 5, 6, and so question 3, basically we're given 1 point and we have different scenarios, right? The first one is slope is equal to 3, second one parallel to x-axis. So this means slope is equal to 0, right? Parallel to y-axis, which means slope is undefined. So let's see what we should do. Okay. So number 3 and number 2 are essentially the same type of question, right? We're given a slope and we're given a slope and we're given a point, and we find the standard form, right? Same as question number 2. So part A. In order to find the standard form, we need to find the point slope form first, right? So first step, we let x, y represent all the points on the straight line. Step 2, we use the slope formula, which is y minus, this is the point, right? So my y minus 6 over x minus 5. And this is equal to slope is given, which is 3, right? So this gives us y minus 6 over x minus 5. That's x plus 5. This is equal to 3, right? And then this gives us y minus 6 is equal to 3 times x plus 5, right? So this is the point slope form. Right, this is a point slope form. Now, in order to find the standard form of the equation, we move everything to the left side, right? So y minus 6 minus 3 times x plus 5 is equal to 0, okay? And then we open the brackets, y minus 6 minus, we factor in the coefficient first, 3x plus 3 times 5, that's 15, right? This is equal to 0. Now we open the brackets, y minus 6 minus, remember we have a minus, so when we open the brackets, this plus sign needs to be changed to minus. Okay, so minus 3x minus 15 is equal to 0. Okay, and this gives us minus 3x plus y, minus 6 minus 15, that's minus 21, is equal to 0. Okay, equal to 0. So this is the standard form. Okay, if you want to check if the answer is correct, you simply plug this number in the equation. If the equation holds, then that means we found the correct expression. If it doesn't, then there must have been something wrong with our calculation. Okay, so we can check. If we plug this point in this equation, that will be -3 times -5 plus 6 minus 21 is equal to 0. Right? So -3 times -5, that's 15, right? So 15 plus 6 minus 21, that's 0. Is it true? Does the equation hold? 15 plus 6, that's 21, right? 21 minus 21, which is 0. So it's 21 minus 21, which is equal to 0. So the equation hold. So that means the expression that we found here is correct. Okay. So this step is extra. Okay. This step is not mandatory, but I only did that because if you have time in your exam, you should do this extra step to make sure that your calculation is correct. Okay, because even for me, I study a lot of math, but even that, I can't guarantee that all my calculation is correct. Okay, sometimes a small mistake might lead to like a super wrong answer. Okay, so that's part A. Part B, parallel to x-axis. By now, we need to know how to translate these words in math language. When we say a straight line is parallel to the x-axis, that means the straight line is horizontal. If a straight line is horizontal, that means the slope of the straight line is equal to 0. Okay, we've seen enough questions to know this. Okay, so now the question becomes, we are given this point and we're given a slope which is equal to 0. Okay. Again, step 1. We let xy represent all the points on the straight line, right? And number 2, we use the slope formula, which is y minus 6 over x minus 5. And in this case, we know that the slope is equal to 0. Okay, slope is equal to 0. So this gives us y minus 6 is equal to 0 times x plus 5, which is equal to 0, because anything times 0 is equal to 0. So this gives us y is equal to 6. Okay, y is equal to 6. So this is the expression of the straight line. Okay, this is the expression of the straight line. Technically, there's no standard form of this expression, but you have to, if you really want to write it in the form of like a standard form, I mean, you can technically. So you can write it as 0x plus y minus 6 is equal to 0. So technically, this is the standard form, but like no one writes the expression like this, right? Because it's just too extra. It's not necessary. Okay, but technically, you can. Okay. So that's part B. Part C, parallel to the y-axis. So now, again, when we see words like this, parallel to the y-axis, that means the straight line is vertical. And we've seen enough questions to know that when a straight line is vertical, that means the slope is undefined. Okay, undefined. So first step, we let xy represent all the points on the straight line, right? Second, m is equal to y minus 6 over x minus minus 5, right? And this is undefined. This is undefined. What does this mean? What does this mean? This means the slope must be of the form some number over 0. Some number over 0. Okay? So in this case, we know that this straight line must be equal to x plus 5. Okay, x plus 5 is equal to 0. Okay. Let me think how I can explain this clearly. Just give me 1 second. Okay, so let me try to explain this better. Okay, so when the slope is undefined, we know that the slope must be of the form, let's say, some number, let's call it c, over 0, right? And this gives us y minus 6 over x plus 5 is equal to c over 0, right? Because only in this case, the slope is undefined, right? And here, I don't know if you guys know this. So if we have two fractions like this, a over b times a over b is equal to c over d. We have something called cross multiplication. So this gives us AD is equal to BC. A times D is equal to B times C. So we can use this theorem in this question. So this gives us 0 times y minus 6 is equal to c times x plus 5. Where c here is just a real number. Okay, and 0 times y minus 6, that's just 0, right? So the whole thing is just 0. Okay, and because c is just a 0 number, we can cancel c. We can divide c, right, on both sides of the equation. So this whole thing will just become x plus 5 is equal to 0. Okay, and this is just x plus 0y plus 5 is equal to 0. So this is the standard form. Okay, this is standard form of the equation. Okay. This question is a little bit difficult to understand because, you know, like when we deal with straight lines that are parallel to the x-axis and parallel to the y-axis, it's always relatively more difficult, right? Because we need to deal with special slopes, right? But just remember, if a straight line is parallel to the x-axis, that means the straight line is horizontal, which means the slope is 0. If a straight line is parallel to the y-axis, which means the straight line must be vertical. If a straight line is vertical, that means the slope must be undefined. Okay? So that's question 3. Question 4, determine the equation of a line which lies on the x-axis. Determine the equation of a line which lies on the x-axis. Lies on the x-axis. Oh, okay. Let me tell you, let me show you what that means. So we have x and y, right? X and y. And the question is asking us to find the equation of the line that lies on the x-axis. So this straight line. Okay, there isn't much to talk about. The equation is y is equal to 0. okay, y is equal to 0. Why? Because on this line, all the points on the straight line have the same y coordinates, which is 0, right? But the x coordinates are different. Okay, so the equation is just y is equal to 0. Okay. And number 5, determine the equation of a line which lies on the y-axis. It's the same, right? I really don't think you need to like really prove or like really need to do all the calculation. You can just remember this. Okay, x, y. So now we're looking for the expression of the straight line that lies on the y-axis. So the expression of this straight line, of the straight line that lies on the y-axis is x is equal to 0. Okay, you can simply remember these two as conclusions. Okay, I don't see the point of like doing the calculation. Okay, find the equation of a line passing through the origin with slope 1. Okay, so this question is worth more effort. Okay, find the equation of a line passing through the origin. This means 0, 0 is on the straight line, right? So question number 6, this is basically the same type of question where we are given a point on the straight line and a slope of the straight line, and we need to find the equation of the straight line, right? There's nothing new here. So how do we do that? Remember, we define x, y, right? So we let x, y represent all points on the straight line, right? And the second step is we use the slope formula, okay? Y minus 0 over x minus 0. And the slope is given here, which is 1, right? So this gives us y over x is equal to 1. And this gives us y is equal to x. Okay, so this is the expression of this straight line. Okay, remember y is equal to x. This is a very special, very basic but special straight line that you will see a lot in the future. Okay, because a lot of properties of linear relations are the best in how to say that. A lot of teachers, including like university professors, they really like to use y is equal to x to explain a lot of properties of linear relations, because this is just too easy. It's just too simple. And yet it has all the properties of linear relations. Okay, so remember this. This is quite important. So that's question number 6. Number 7. Find the equation of a line that passes through the given pair of points. Express the equation in standard form. So here, starting from question number 7, we are not given the slope anymore, right? We're just given 2 points. So that means the first step will be find the slope, right? So let's see part A. Part A, the straight line passes through 2 points, which is 2, -1, and 4, 3. So the first step, instead of letting x, y represent all the points, the first step now is to find the slope. So we use the we use the slope formula to find the slope of the straight line first. Is equal to, so the m is equal to 3 minus 1 over 4 minus 2, which is equal to 3 minus 1, that's 4. 4 minus 2, sorry, 4 over 2, that's just 2, right? So now we know the m is equal to 2, right? So now it becomes the old type of question where we know the slope and we know a point, right? So now we have the slope and we have 2 points. We have more information than needed. So we can just pick either of these 2 points, okay? So now we let x, y represent all the points, and we use the slope formula again. Let's pick this point. Let's use 4, 3. So m is equal to y minus 3 over x minus 4. And the slope over here is found here, right? So it's equal to 2. Okay, so this gives us y minus 3 is equal to 2 times x minus 4. So this is the point slope form, right? This is the point slope form. Now we need to change this point slope form to standard form, which means we need to move everything to the left, open the brackets, organize the equation, and write the equation in the standard form, right? So this gives us y minus 3 minus 2 times x minus 4 is equal to 0, right? Y minus 3 minus 2x minus 8 is equal to 0. Y minus 3 minus 2x, again, minus before brackets. So this minus needs to be changed to plus when we open the brackets. Plus 8 is equal to 0. We move the x term to the front, because that's what the standard form looks like, right? The x term is the first term, right? So minus 2x plus y minus 3 plus 8, that's plus 5, is equal to 0. So technically, if you are in the exam, technically up to this point, you're done. Okay, you're done. But if you have time, like I said, you can check your answer. You can, for example, you can plug in these 2 points and see if this equation holds. If it does, that means this equation is correct. That means there's no mistake in your calculation. If the equation doesn't hold, then that means your calculation was wrong. Okay, we can just quickly check it. So let's use 2 minus 1. Okay, so minus 2 times 2 plus minus 1 plus 5 is equal to 0. So if this equation holds, then that means the expression right here we found is correct. Okay, so minus 2 times 2, that's minus 4, right? Minus 4 plus minus 1, that's minus 1, plus 5 is equal to minus 4 minus 1, that's minus 5, minus 5 minus 5 plus 5, that's 0. So the equation holds. Okay, so this means the expression right here is correct. Okay, let's do another example. Part B. Again, we have 2 points now, right? 2, 1/2. So 2, 1 over 2, 3 minus 4. First step, find the slope, right? The slope is equal to minus 4 minus 0.5 over 3 minus 2, which is equal to minus 4.5 over 1, which is minus 9 over 2, right? Because minus 4.5 is equal to minus 9 over 2, right? Okay, so that's the slope. And now we have slope, we have 2 points, we have more information than needed to find the expression, right? So now we can let x, y represent all the points on the straight line, and then we use the slope formula again, right? Let's use this point, y minus 4 over x minus 3. And the slope here is found in the first step, right? Which is equal to minus 9 over 2. This gives us y minus 4, that's y plus 4. So y plus 4 over x minus 3 is equal to minus 9 over 2, right? And this gives us y plus 4 is equal to minus 9 over 2 times x minus 3, right? So this is what form? This is the point slope form, right? This is point slope form. And now we need to change the point slope form to the standard form. Okay, so we need to move everything on the right side of the equation to the left side of the equation. And we need to open the brackets, we organize the equation, and we write the expression in the form of standard form, right? So y plus 4 plus what 9 over 2 times x minus 3 is equal to 0, right? Now we open the brackets, y plus 4 plus 9 over 2 times x minus 9 over 2 times 3, that's 27 over 2 to 0, right? And then we move the x term to the front, 9 over 2x plus y. So we have plus 4 minus 27 over 2. Plus 4 is equal to 8 over 2, right? 8 minus, so let me write this out. So 4 can be written as 8 over 2, right? Minus 27 over 2 is equal to 0. So 9 over 2x plus y. 8 minus 27, that's minus 19, right? So minus 19 over 2 is equal to 0. So this is the standard form that we need to find. Okay, so again, technically up to this point, if you're writing an exam, up to this point, you're done. Okay, but if you have time, it's always a good idea to check your answer. How do you check your answer? You plug these 2 points or just one of these points to this equation and see if the equation holds or not. If it does, that means your equation is right. If it doesn't, then it means one or some of the steps over here are wrong. Okay, so let's try. Let's use this. Let's use the first point here to check. Okay, 2 1/2. So x is equal to 2, right? So 9 over 2 times 2 plus 1/2 minus 19 over 2 is equal to 0. So if the equation holds, that means the expression here is correct. Okay, so we have 9 over 2 times 2, that's just 9, right? That's just 9. 9 plus 1 over 2 minus 19 over 2 is equal to 0. So 9 is equal to 18 over 2, right? 18 over 2 plus 1 over 2, that's 19 over 2. 19 over 2 minus 19 over 2 is equal to 0. So this means our expression is correct. Okay, it's correct. So I showed you 2 examples. Okay, part C, I'm not gonna do part C because I'm lazy. It's because the numbers here are very annoying. Okay, I don't like messy numbers because these numbers, they don't contribute to any more, they don't contribute to any more than the first 2 questions. Okay, the first 2 questions, the numbers are neat, right? The third question, the numbers are really messy, and yet they literally teach us the same method. There's nothing more to part C, right? So so I'm just gonna skip part C because the numbers are too messy. Okay, but the method is the same. The steps are the same. Okay. Okay, so we have 2 more pages. I'm going to explain the other 2 pages in the next video, just because I don't want the video to be too long. Okay, I'll see you guys in the next video.